All right, in this video, we are going to talk about database input and output. So, if you remember last time we talked about file organization, we said that a field holds a single factor attribute of an entity, and those basically corresponded to the columns, right, in our data file. A record is a collection of related fields, and so those corresponded to the rows in our data file. And then a file is a collection of related records, and then files are integrated into a database. Okay, so so the way that the databases normally work, there's a couple of different kinds, but sort of the more traditional kind. Um, Files are it's called a table in the database. And so, even though we've used file here because we started off talking about data files, we're going to start calling these tables when specifically we are talking about databases. And historically, the file approach, like kind of we've been doing, is the way things started off. Um, so, um, so all the data was kept in files, and then we processed files pretty much exactly like we did in the previous video for the payroll example. So that's kind of like, you know, state of the art in the 70s or something like that, right? 1970s. Um, so as the amount of data that people were collecting grew and grew, they started realizing, hey, wait a second, keeping it in a bunch of different files on your computer is not necessarily the best way to go. So people started moving towards keeping their files in databases, and databases are a much more efficient way and organized way of keeping track of data. Okay, it avoids a lot of the problems that you have with files if the database is designed and implemented correctly. Um, Over time, your files might be corrupted. There might be some instance where you have sort of the same type of data in two different files, and so that's not necessarily inefficient. But then problems come up where maybe one file gets updated and the other file does not. So you essentially have um, two different types of or pieces of data for sort of one entity in the database. So maybe, you know, so something's not right there. Maybe it's an address, two different addresses, or something like that in the field, or it could be much worse. You can imagine that could lead to some problems, and you know things like medical records, right? That would be a very dangerous situation, right? If medical records got corrupted or the data in there was wrong, and you know who knows what could happen in that case, right? Somebody gets treated with something that they are allergic to or something like that, and that would be bad. So databases are kind of evolved, and they're very organized, and the uh, the way that the data is stored in the database, people have studied that quite a bit, and we really have good and efficient methods of storing data in databases. So it's really a level beyond what this is, what storing data in files used to be. Okay, and we can't go too deep into that. That's a whole area in and of itself of um, maintaining databases and how to best organize data within databases. Here, what we just want to talk about is basically input and output of involving databases, because most modern applications, that's what you're going to be using. You're not going to be using files. Okay. So there's a couple of types of databases. There's a relational databases. Those are modeled on the mathematical concept of a relation. And the relational databases use a language called structured query language, or SQL, right, to manipulate and administer and query the database. All right, so it's kind of a programming language unto itself. You don't need to know SQL in this class. I'm just going to give you the SQL commands and show you how to use it. Um, if you later on want to use this database stuff in one of your applications, then that is good to say that you have some experience doing that. And if you have questions on SQL and how to do that, then you can just let me know, and I'll let you know what the SQL statements that you need are in there. Okay. All right. And then the other type of database, which we will not talk about, but you kind of need to be aware of, are NoSQL databases. And so those don't use this relational model, and therefore they don't use SQL, right, to make queries. That is designed to handle extremely large amounts of data. So this relational databases do a really good job of organizing and structuring the data so that it can be extracted easily and it won't get corrupted easily. And so the issue, though, is that there's some overhead with that. And if you're talking about massive amounts of data, think about Google or Facebook or Twitter or Amazon, right, that are carrying out operations on a massive scale, then the relational database, the data at some point becomes too much for this, and the resources are too much. So they have developed some other NoSQL databases that don't use the traditional relational model. We will not talk about that in here. We'll just use the an example of a relational database. Okay. All right. So a database management system is a collection of programs that manages database structure and controls access to the data stored in the database. So some relational database management systems, SQLite, and that's the one that I'm going to show you. The advantage of SQLite is that you don't need to set up a dedicated server to house the data. Okay, it's just housed in a file, but a special file, not like the files that we've been using essentially. It can have all the structure of more complicated tables that are stored on a server. Okay, Oracle database, MySQL, Microsoft SQL Server. So there's lots of different types of database management systems. They all have all these relational database management systems. They all have different flavors of SQL, and so the one we'll stick with this SQLite here. Okay. And then some NoSQL examples. The one I hear about the most is this MongoDB. I haven't really used that all that much. And then there's many others, because now that's become a fairly large thing with internet and big data companies. Okay. All right. And so the one I'm going to be using in this video is just called DB Browser for SQLite. It's really just an interface with SQLite. That's all this is. But this is free and it's cross-platform. So you just go here and you can download it. And so this is a really nice little tool for just looking into a database. All right. So I'm only going to use this really for illustration purposes. I'm not going to be using it for to manipulate the data, although you certainly can, right? This would be like a database manager, somebody whose job it is to just maintain the database and manage it. They might use a tool like this, right? This class is computer programming, right? And so what our goal is here is we want our applications to be able to interface with the database. We want to be able to read data from the database. We want to be able to write data to the database. Okay, and so nowadays, most apps that you have on your phone and things like that is what they are going to be doing. They are going to be interfacing with the database. All right. So database input and output in Java, right? What you would use is JDBC. That stands for Java Database Connectivity Driver. All right, and there's different drivers for different types of databases, right? And SQLite is the one that I'm going to use. So what you want to do to get access to that is open up this link, and that's going to go to this guy's GitHub page. Let me take this down first, because I forgot to. I want to show you the install process, and to do that, I am going to need to delete some things in my thing here. So you would just go and download this off the download page here, this version. All right, and then you want this jar file right here. Whatever, I'm just going to use whatever the latest version is. All right, so you would download that. All right, and then let me reset this so I can show you how it goes. Okay, and then you would have to remember where where you downloaded that jar file to, right? And so then what you want to do, and the instructions are here in the notes. Once you download that, right, then you would want to go in JGrasp, go to Settings, Path, Class Path, and Workspace. And a jar file is a Java archive file. And so that's a way of bundling together some Java classes together so that you can use those in applications. So in your application, you know, when you deploy this, you might do it in a jar file. You would have to also include these files that you're using as well. All right, so go to JGrasp. And then what we want to do is go to Settings, right? Path, Class Path, Workspace. Now mine's already on Class Paths, but it might be on a different one for you, right? So just click on the Class Paths tab, and then you want to go to a new one. And then you just tell it where the jar file is here. All right, so mine's in Downloads here. And then click OK. So that adds that in there. So you can see I have a couple here and here. All right, and click on Apply, and then click OK. All right, so you have to do that, otherwise this thing is not going to run the examples in there. Okay. So let's see. I want to go back here to the notes. All right, so that's the installation. Okay, and we're just going to go through this very short example here. And then we'll separate the other examples into videos of their own. All right, so we want to look at this create database example. All right, and this shows a really minimal working example about how to create a database file. All right, in the next example, what we're going to do is convert our data that's in a file. We're going to put it into a database so that we can use that. All right. So all this program does is create the database, and this is actually, if you go back and look at the GitHub page where we downloaded it, the author of this SQLite JDBC driver has some examples, and it's just pretty much exactly the same example he has there on his page. Okay, so what you would do, right, in order to create a database, right, is to first create a connection. All right, a connection object here in a try with resources statement. All right, so when you do that, it's over here. It's driver manager, so you have to import this driver manager class dot get connection. Inside is you need a string, right, and then the name of the file that you want to create goes over here, sample.db. So it's going to be JDBC SQLite and then the name of your file will go right over here. Okay. All right, and then once you create that connection in the try with resources statement, it does have a checked. This method has a checked, throws a checked exception, and that is a SQL exception. So you have to have a catch block for a SQL exception down here. All right, then what we want to do is create a statement object. Again, that is java.sql.statement. All right, and then you would use the connection object that you created up here, and then you're going to create a statement. So these statements that we are going to create, and you can see them down here, these are statements that are written in the SQL language, SQLite, right? That's the SQL version flavor that is used with SQLite, which is what type of database that we are using. Okay. Next up, after you create the statement, then here they're setting the timeout for the query to 30 seconds. So that way, if something, the database is busy or something like that, it's locked and they can't get to it, then it will wait 30 seconds for that database to unlock. Okay. And so that's one of the issues that's surrounding databases is that you have multiple people accessing data at the same time. You have to be careful, right, about how the data gets accessed and changed. All right. So here I've run this without this query timeout statement, but like I said, the author has that in there, so it's probably a good idea if we put that in there. All right, this next statement we don't really need right here. So to execute a SQL statement on the database file, we would do statement dot and then execute update. Right, so we go through this statement object that we created that's connected to this connection. And this SQL statement, again, this is a SQL statement, and it says drop table if exist person. So what will happen is if there is a table named person in the database file, this will delete it. Okay, so it will delete everything. And really, we don't need that the first time because you can see there's no database file over here that's been created at all. But the thing is if you're running this over and over again, if there is a person table already in the database, it's going to throw this SQL exception and it's going to not do what you want. So, and that's kind of annoying. So when you're testing and doing those things, it's a good idea to have this in here, okay? Or at least deal with it in a more appropriate way than I have. All right, next up is we are going to issue the SQL statement that creates a table, right? Create table called person. So in our database, we'll have a table called person, and right, the fields are ID and name. Okay, so I have a field called ID that keeps track of, say, the person's ID number, and then I have a field called name. Here, I also have to give the data types of those fields. So in this case, right, ID is an integer. And now you may say, well, in Java, it's int. Why are you using integer there instead of int? Well, these are data types in the SQLite language. Okay, so it's integer, and then you can put string, but I think text is a more fundamental data type than string here. Okay, so their name is a string or text, ID is an integer. So that will actually create the table. Okay, and then what you want to do then is now start putting data into the table. So you can see here is another SQL statement. It says insert into person. So that's the person table that we just created up here in line 18. And then values, and then I say what values to put in. I want to put a 1 as the ID number for this person, right? So these are basically the records that you're going to put into this table. All right, so this person has an ID number of 1. Their name is Leo. And notice, right, that Leo is in single quotes. Okay, and so the reason why is because that's the syntax of the SQLite query language. Okay, so their SQL requires these strings to have single quotes around there. So that's why it's in single quotes. And then I do the same thing with another value as well. All right, so this person has an ID number of 2, and their name is Yui. Okay. All right, and so when I run this, right, I'm going to compile it first, and then I'm going to run it, and then you'll see, right, Over here, there's no database file. When I run this, it's going to create the database file. All right, so up here, over here, you see, boom, there's your database file, sample DB, right? It matches this right here. Okay. All right, so now the thing is when you try to open sample DB up, it's going to be a binary file, I'm pretty sure. Yeah, see, so it's a binary file. It looks like that. It's really hard to see what it is. So just to show you what it's going to look like, I'll bring it up in this interface here, and we can look at it. We don't need to do this, right? Other than to say, if we're, like I said before, if you were the person whose job it was to maintain the database and make sure everything's going with it, the administrator, right? The database administrator, then you would be checking things like this, and a lot of end users of the database also might have tools like this that they use. But remember, for us, right, we are really wanting the application to do the work, not the user. Okay, so what you would want to do is we need to open database, okay, and you can see, let's see, we're in the demo directory. So there's sample DB that we created, and I'm going to open it up. All right. So open, hopefully you can see that the writing's pretty small, but over here we have DB schema, the database schema. So that tells you, right, all the tables that are in there. If you expand that, you can see what the fields are in that table, ID and name, and what their types are as well. So that's basically what was going on here. When we were creating this table, this was the schema, right, for that table. All the fields and their types and everything like that. All right, and now in DB Browser for SQLite, what you want to do, if you want to actually, this will tell you the structure of the database, all the tables. We only have one table in here, but if you want to look through the data, you click on this Browse Data tab, okay? And there you go. You can look at all of the tables that you have. We only have one table in here. It's called person, right? And you can see there's Leah with ID 1 and Yui with ID 2. Okay. So so there's our database that we've created. We've got everything set up the way we want it. Just one other thing about DB Browser for SQLite, you can modify your database in here and do a bunch of stuff in here. You can also execute SQL commands on your database in here as well. Okay. And if you do decide to mess around with this, then if you make changes, make sure you click the Write Changes button before you quit. A lot of people are used to just the changes updating automatically, but here I don't think it will do that. Anyway, we shouldn't have to do that. All right, so I'm going to close this. And go back to JGrass. So this code right here created our database file. Just one more thing, right? If I'm going to show you what happens if I comment this drop table if exists person. If I try to run this again, and it's going to give me an error. And you can see the message that you get is that the table already exists. So that's the thing. If you're testing your code out and this table is already created in there, then none of these commands are going to run, right? Because the table is already in there. So that's why this little statement is in there. You would just remove that, and then you're writing and you want to test it out a little bit. So you run it. You can see this time I don't get the error, because what happens is that that table is deleted. It deletes that entire person table and then recreates it all over again from scratch. Okay, so that's good for testing. Obviously, right, you in your application, right, you would not want that, because that would delete any data that you had in there before every time the app opens up, and it would be starting fresh. And that kind of defeats the purpose of having the database. It's supposed to be that your all the data from the previous sessions is in there. Okay. All right, I think that is it on this one, and then we will separate the this out in the next video. we will convert that payroll data that we had as a comma separated value file. We will convert that into a database.